Hi everyone, and welcome back to my channel. Please remember to like and subscribe so that you're kept up to date with everything that I upload. I recently did a video on the quadratic function. I did a graph interpretation video on the quadratic function or the parabola. Today I'm going to be doing a graph interpretation question on a hyperbola. This question will be taken directly from a grade 11 GDE past paper. Before we get into the graph interpretation question, I just want to touch base with the formula. Make sure that we all understand exactly what the letters stand for. So we have the formula y is equal to a over x plus p plus q. Now we see the p again. And remember, when we see a p in a parabola, a hyperbola, a trig function, whenever we see the p, we go, oh no, this is complicated. No, it's not complicated. Just remember, the p changes its sign. That's all there is to it. So whatever it is in the equation, it's a different sign in the diagram and vice versa. The q, however, remember, remains the same sign so the equation and the diagram, same sign. We have the a at the top, so a over x plus p. So the a, again, remember, is not the gradient. You cannot have a gradient of a curve. So the a is the direction or the shape of the graph. If the a is greater than 0 or positive, then that means that this graph will lie in quadrant 1 and quadrant 3. If a is less than 0 or negative, it will lie in quadrant 2 and quadrant 4. The p-value is the vertical asymptote of this graph, and the q value is the horizontal asymptote of this graph. Now, what does asymptote mean? Remember, asymptote is a line that the graph can never touch. So the graph gets really close to the asymptote, but it must never touch or go through the asymptote. So when we have a vertical asymptote, remember we have our vertical lines, and a vertical line has an equation x equals something, depending on where it is on the graph. So for our p-value, for our vertical asymptote, the equation of the vertical asymptote is x is equal to negative p. So whatever p is in the equation, it's the opposite sign. X is equal to negative p, vertical asymptote. For the horizontal asymptote, remember, if we have our horizontal lines, those all have the equation y equals something. And so the horizontal asymptote is y is equal to q. Doesn't change its sign. Now, when we're talking about a shift, the p and the q, as well as our asymptotes, they also operate the shift or are responsible for the shift. They don't operate it. It's not like a shift. No. So they don't operate it. So the p and the q are responsible for the shift as well. Now the q, the same as with our quadratic function or our parabola, the q shift is up and down. So we have an up and a down shift. If we're shifting it up, we're adding to the q. If we're shifting it down, we're subtracting from the q. The p-value is our left and right shift. Now remember, in your head, right, the numbers are getting bigger, you want to add, therefore you're going to subtract. Numbers are getting smaller to the left, you want to subtract, therefore you're going to add. So a shift to the left, we add, a shift to the right, we subtract. Then we have our axes of symmetry. Now we have two axes of symmetry for a hyperbola, and you need to know the equations off by heart. So I suggest that you write it down. I actually suggest that you do all the notes that I'm making handwritten so that you can study from them. But we have two equations. Y is equal to x plus p plus q, and y is equal to negative x minus p plus q. So those are two equations for our axes of symmetry. Okay. Now, y equals x plus p plus q is obviously our positive axis of symmetry. The gradient is positive 1. Y is equal to negative x minus p plus q is our negative gradient axis of symmetry. I always suggest that you ensure that you write everything in words and make sure it's on your diagram. When you're working with functions, trig, geometry, I recommend annotating your diagram. So you just make little markers, make little drawings all over your diagram to make sure that everything you have is represented on the diagram. The other thing I recommend is, as you answer a question, go back and fill in the information on your diagram because you might need it for a future question. So if we look at the question, the diagram below shows the graph of f of x is equal to 1 over x plus 3 minus 1, and g of x is equal to a half x. The graph of f intersects the x-axis at A and the y-axis at B. the graph of f and g intersect at points C and D. So if we pause real quick on this information that we were given, our f of x equation 1 over x plus 3 minus 1, I can tell that this is a hyperbola. Why? Because the x is in the denominator. And g of x is equal to a half x. I know that that is a linear graph or a straight line graph. If I look at my g graph over here, I can see that this g graph intersects at 0. So the y-intercept is 0, and do you agree that we could always add a plus 0? It's actually a half x plus 0. If I'm looking at my hyperbola equation, I can take information straight out of that equation. So I have plus 3 and I have minus 1. So the plus 3 is my p-value. So the p-value there is the positive 3. So that represents my vertical asymptote. So my vertical asymptote is the asymptote that goes up and down. Okay, so if in the equation it was a plus 3, that means that over here on my diagram I have a minus 3. Also, another hint is we have the origin over here, and you can see that the asymptote is on the left-hand side, so therefore it has to be negative. Then we have our horizontal asymptote of negative 1. So we have our horizontal asymptote over here, crossing there, which means that I can fill that value in as negative 1 as well as the negative 3 for the vertical asymptote. The graph of f intersects the x-axis at A and the y-axis at B, so that's just talking about your x and y intercept. And the graph of f and g intersect at points C and D. So they intersect at points C and D. So that means that at point C and at point D, those are points of intersection where the two equations are equal to each other. And that's something that you obviously need to know. Remember, I always recommend that you look at your diagram. Okay, why? Because you can tell whether you have a positive or negative A value, you can tell the shape of your graph, you can tell the direction of your graph, you can tell whether an intercept must be positive or negative based on where it lies on the graph. You can see points of intersection. So for example, if I'm just looking at the graph, so I want to just spend a little bit of time just looking at this graph. If I look at C and D, I can tell that based on C and D, based on their location on this graph, that D's x coordinates will be smaller than negative 3 because it's past negative 3. Here's negative 3 and here is D. So there's a distance here. So I don't know what it's going to be, but I know it's going to be a number smaller than negative 3. So that's why I like to look at the diagram. If we look at the first question, write down the equations of the asymptotes of f. Now, when we're writing out the equation of the asymptotes, it cannot be in the form of P and Q. Okay, writing out the equations have to be in the form of x and y. So when I'm writing out the equation of these asymptotes, I can say the asymptote of x is equal to negative 3 and y is equal to negative 1. Now I read that from my equation, I read that from my P and Q value, but I'm not going to say P equals negative 3 and Q equals negative 1. The next question says, determine the domain of f. Now remember, we have range and we have domain. D comes before R and X comes before Y. So domain are my X values and range are my Y values. So that's just an easy way to kind of remember the difference between domain and range. So domain, we're working with X's, range, we're working with Y's. So domain and range are the minimum and the maximum values. So if I'm looking for the domain of this graph, I would look at the X values. If I look at this graph, this part of, so I'm just going to kind of scribble over it in black over here. So that's the one corner. That's the other points. This graph keeps going in that direction, and it keeps going in that direction. Now, if I'm looking at the domain, that means that I'm looking at the x values. So here's my x-axis. So I'm looking for everything going in those two directions. So that means that I'm looking over here and I'm looking over here. Now, do you agree that the hyperbola, that is going to keep going? It's got arrowheads, which means that it continues and it keeps going and keeps going and keeps going, which means that it's going in both of the directions, negative infinity and positive infinity. However, this is a hyperbola, and a hyperbola has an asymptote. So when we're doing our domain, we have to remember that it's all the x values from negative infinity all the way to positive infinity, but it excludes the asymptotes. If I were doing the range of a hyperbola, it would be exactly the same. All the y values positive and negative, except it would exclude the asymptote. So if I'm writing out the domain of this graph, x is an element of the real number system. What does that mean? That means that x can be any value in the real number system, but it cannot be -3. So it can be any number that's real except -3. There's another way we could write it. We could say that x is an element. We could use the union of the two. So we could go from negative infinity to -3, from -3 to positive infinity. So those are the two ways that we could write it. Remembering here, infinity always has a round bracket, and these round brackets by this -3 is just telling me that it's excluding -3. So my starting one excludes -3, my ending one excludes -3, which means that I've excluded -3. The next question says calculate the length of OB, and then the next question says calculate the length of OA. Remember, when we're working with length in graph interpretation, we have three types of lengths that we can work with. We have a vertical length going up and down, a horizontal length going left and right, and a diagonal length going, well, diagonally. So, if we have a vertical length going up and down, we're going to do y top minus y bottom. So whether it's the actual y coordinate or if it's the equation y top minus y bottom. When I'm doing a horizontal length, I like to do x right minus x left, because that just limits the number of times you're going to have a negative length that you then need to change to a positive length, because you need to remember that length is always positive. Then for a diagonal length, we can't do y top minus y bottom. We have to do some form of a right angled triangle. So we're either going to work with trig or we're going to work with Pythagoras, but we'll need to get the other two lengths in order to calculate that diagonal that we need. So if I look at OB, OB is this length over here. So it's this vertical length. And AO, or OA, is this horizontal length over here. So O in both of these instances is 0, because O is at the origin. Now we have B and A. B is the y-intercept and A is the x-intercept of F. So I'm able to determine what the y-intercept of F would be, and that would give me the coordinate at B, which would enable me to calculate that length. And then A is the x-intercept of the same graph. So if I find the x-intercept, I'll have A's coordinate and then I can find the length. Okay, at point B, we know that x is equal to 0. Why? Because point B is the y-intercept. So therefore, the equation is y is equal to 1 over x plus 3 minus 1. But x is 0, so 0 plus 3 minus 1. So I'm saying that this x equals 0 becomes the 0 over there. So therefore, y is equal to, obviously I just type that straight into my calculator, and I get negative 2 over 3. Now, negative 2 over 3 is the coordinate. So if I were to do y top minus y bottom, I could say that OB is equal to 0, because that's the coordinate at the top, minus the coordinate at the bottom, which is the B. And 0 minus 2 over 3 is 2 over 3, and it's a length, so I'm going to write units. What I'm going to do is I've got that B value now, so I'm going to write it in as negative 2 over 3. At A, y is equal to 0. Why is y equal to 0 at point A? Because it's the x-intercept, and at the x-intercept, y is equal to 0. So now I'm going to replace the y with the 0, and that is equal to 1 over x plus 3 minus 1. Now I want to solve this equation, so I'm going to take the negative 1 across, and it's going to become a positive 1. So now I have 1 equal to 1 over x plus 3. So this negative 1 is what went across and became a positive 1. Now to solve this, I am going to multiply both sides by x plus 3. Why? Because that's going to get rid of the x plus 3 in the denominator, and it's going to put it in the numerator on the other side. So I'll have 1 into x plus 3, which is obviously just x plus 3, but I like to just show all the steps, especially when I'm teaching. So I have 1 into x plus 3 equal to 1. So that means I have x plus 3 equal to 1. So x is equal to negative 2. So that means that I have x equal to negative 2. So this coordinate here of A is negative 2. However, it's a length. Therefore, OA is equal to x right minus x left. X right is 0 minus x left, which is minus 2. 0 minus minus 2 is 0 plus 2. So OA is 2 units. The next question says, determine the coordinates of C and D. Determine the coordinates of C and D. If we look at C and D, we discussed it in the beginning. C and D are the points of intersection of these graphs. Now, the point of intersection means that at that point, the two graphs are equal to each other. So I'm going to take my equation and I'm going to make them equal. So I want the points of intersection. And for the point of intersection, equation 1 is equal to equation 2. So equation 1 is the hyperbola's equation, which is 1 over x plus 3 minus 1. And that is equal to the linear equation, which is a half x. And I'm going to write a half x as x over 2. Because x over 2 is a half x. But it's just going to make it easier because now I need to find an LCD. Alright, so it's an equation, but I'm adding and subtracting, which means that I need an LCD. I'm going to just bracket that x plus 3 so that I don't forget it. So now I have the LCD equal to 2 into x plus 3. Why 2 into x plus 3? Because I have a 2 in this fraction and I have an x plus 3 in that fraction, and both of those denominators need to be accounted for. So I have a denominator of 2 into x plus 3. Now when I solve this, what is missing from this fraction? If I look at the denominator, I have x plus 3, so what is missing? Just the 2. Remember, when you're working with an equation that consists of fractions, you can find the LCD and drop the denominator in an equation. When it's an expression, that's when you need to keep the denominator. So if I look at my first fraction over here, I have 1 over x plus 3. What's missing? The 2. So it will be 1 times 2. Minus 1. So this minus 1 is staying the same. So that's what this minus 1 is. What's missing from this? Well, this doesn't have any denominator at all, so it's missing the whole thing. So it's missing, so it's 1 times 2 into x plus 3. and that is equal to, carry down my x, what is missing from this fraction, from that fraction the bracket is missing, of x plus 3. Now I'm going to simplify this. So 1 times 2 is 2, minus 1 times 2 is minus 2, and that minus 2 is then going to go inside that bracket. So minus 2 times x is minus 2x. Minus 2 times positive 3 is negative 6. Equal to x times x, which is x squared, and x times positive 3, because this x is going into that bracket, x times positive 3 is positive 3x. Now I can simplify everything, because in order to determine these coordinates, I'm going to have to factorize this. Remember, when you're factorizing a quadratic equation, how do I know it's quadratic? The degree is 2. When you're factorizing a quadratic equation, everything to one side, make it equal to 0, factorize fully and make each factor equal to 0. So I have 0 equal to x squared, the plus 3x will stay there, but this minus 2x when it goes across becomes a positive 2x, so 3x plus 2x is positive 5x. This 2 and this minus 6 becomes minus 4, and when it goes across it becomes positive 4. So now I have 0 equals x squared plus 5x plus 4, so I'm going to factorize this. To factorize this, I look at my third term. My third term is a positive 4, which means that the signs are going to be the same. What are they going to be? I look at my middle term. My middle term is a positive, which means that they're both going to be positive. I factorize the x squared to be x and x. The factors of 4 are 1 and 4, and 2 and 2. Which of those two sets of factors, when I add together, give me 5? 1 and 4. Everything to one side, make it equal to 0, factorize fully, and then make each factor equal to 0. So that means that x plus 1 equals 0, or x plus 4 equals 0. So if x plus 1 equals 0, that means that x equals negative 1. And if x plus 4 equals 0, that means that x is equal to negative 4. Alright, so now I have x as negative 1 and I have x as negative 4. They wanted the coordinates of C and the coordinates of D. Now all I have are x coordinates. So in order to get the y coordinates, I now need to take the two respective x coordinates and I need to substitute it into an equation. Remember, at that point of intersection, both the equations are the same. Both the graphs are the same, which means it doesn't matter which equation you substitute into, you're going to get the exact same answer. So therefore, y is equal to, so I'll take the easier equation, which is a half x. So a half, in place of the x, I'm going to put minus 1. So that means that y is equal to negative a half. Or y is equal to, the easier of the two equations is a half x. So in place of the x, I put the x value of minus 4. A half times minus 4 is negative 2. So that means over here I have a set of coordinates that go together, and over here I have a set of coordinates that go together. So I have minus 1 and minus a half, and I have minus 4 and minus 2. But they want the coordinates of C and D, so I need to choose which of those belong to C and which of those belong to D. And that reminds me to look. Okay, we need to look at our diagram. So we have x coordinates minus 1 and minus 4. So if we go back to our diagram, we have x coordinates of minus 1 and minus 4. So which one is minus 1? The C would be minus 1 and the D would be the minus 4. That the C is the minus 1 and minus a half, and the D is minus 4 and minus 2. Alright, the last question says, use the graphs to obtain the solution to 1 over x plus 3 is greater than or equal to x plus 2 over 2. It's really easy to get really good at these inequality type questions because they're all kind of similar. So we have our inequality questions where we say, where is the one graph greater than or equal to 0? Where is the one graph less than or equal to 0? Right? Then we have another question where it can say, where is the one graph above the other graph, or where is the one graph below the other graph? Where is the product of the graphs positive, the product of the graphs negative? So once you have done like all of those are the only ones that you can have. Now this is when I really recommend that you watch the quadratic function video, which I'm going to link in the comment section, because in that video I did 2 examples of inequality questions, and I just think that the more you do, the better you'll be. When I look at this inequality question, the 1 over x plus 3 kind of looks similar to something that we have. And something that we have is the equation of the hyperbola, which is 1 over x plus 3 minus 1. Then if I look at the x plus 2 over 2, it kind of looks similar to the straight line graph, and there's just something different between each of them. So what I'm going to do is I'm going to say, okay, I don't really like the way this looks, so I'm going to change the way it looks and without changing the value and see what happens. Because if I look at this x over 2, that could be a fraction, and the 2 over 2 could also be a fraction. So I could rewrite this as 1 over x plus 3 is greater than or equal to x over 2 plus 2 over 2. Now 1 over x plus 3, like I said, is missing the minus 1, but the x over 2, now I've created the linear equation, the x over 2. Then if I look at this 2 over 2, what does 2 over 2 equal? Well, 2 over 2 equals 1. And I can take that 2 over 2, or that 1, across the inequality sign, and it's going to become a minus 1, which means that, therefore, I would have 1 over x plus 3 minus 1 is greater than or equal to x over 2. So I've taken this 1 across the inequality sign and I've said minus 1. Now in that form, I can now see that this is the exact hyperbola equation, or the f of x equation, and this is the exact g of x equation, which means that I can replace that with f of x is greater than or equal to g of x. So that means that this has now changed to f of x being greater than or equal to g of x. So so I'm going to keep the same inequality, but I'm just going to keep changing the way I say it. So it starts off with f of x is greater than or equal to g of x. Well, f of x is the hyperbola and g of x is the straight line. So the hyperbola is greater than the straight line. But greater than means bigger than. The hyperbola is bigger than the straight line. Bigger could also be used as saying above, right? If you're bigger, you're above something that's lower or smaller. So where is the hyperbola above the linear? Okay, so now I've changed this greater than or equal to be above. Or equal, I'm going to add the equal to at the end. But now, where is the hyperbola above the straight line graph or the linear graph? So that's kind of how I've just worked it out in my brain, right? But obviously the more you do, the better you'll be at that, and it will come much quicker and you won't have to reason your way all the way through it. So if I go back to the diagram, I want to know where the hyperbola is above the straight line. So what I'm going to do is I'm going to identify the straight line. So I'm just going to highlight this whole straight line over here. So I'm highlighting it in blue. And then I'm going to highlight the hyperbola in pink. All right, now I'm going to kind of scribble over them so that you can see. All right, so here is the straight line graph. Now, do you agree that you can clearly see where the hyperbola is above and where the hyperbola is below the straight line? Now remember, This question is when the two graphs are above and below each other, but you also have the questions where it says where is the graph greater than 0 or where is the graph less than 0. And greater than or less than 0 will be talking about the x-axis. Greater than 0, where is it above the x-axis? Less than 0, where is it below the x-axis? Don't forget that. Alright, so this one is saying where is the hyperbola above the straight line or the linear. We can see over here, I'm scribbling it out in black. Over here, that hyperbola section is above. Over here, this hyperbola section is above. So it's saying for which x values will the hyperbola be above the linear graph. So that means that this will be, the hyperbola will be above the straight line graph from this coordinate of D going in that direction, going in the negative direction. So from D going in the negative direction, that's when the hyperbola will be above. Then the hyperbola will also be above the straight line graph or equal to the straight line graph from C going in this direction. But remember, there is an asymptote there, so it can't be equal to -3. So for the hyperbola to be above the linear graph in this picture, it has to be from D going in the negative direction, so anything less than -4, or between C and that asymptote of -3. So therefore, x has to be smaller than -4. But I'm going to look here, my crocodile teeth have a tongue, which means that my crocodile teeth need a tongue. So x must be smaller than or equal to -4, or, so that's between point D, or point C, it needs to be between -3 and -1. Now, it can't be equal to -3 because -3 is the asymptote. So it can't be equal to -3, but it must be equal to -1. I really do hope that you've enjoyed this video, that this video has helped you, and most importantly, that you've taken down notes while I've been talking. If not, rewatch it, take down the notes. The more you do, the better you'll be. See you soon.